All right, so today we're going to try to graph a polynomial function. And this will be a order 3, and the order 3 is determined by the highest power. Okay. So, and we're going to do this with a sign table, S-I-G-N, right? Sign, S-I-G-N, sign table, whether it's positive or negative, but we got to locate zeros. If we're going to figure out the zeros of this thing, we have to factor it. And again, we haven't done a lot of factoring. We've done a lot of quadratic factoring, but not much at all of cubics, except for items like this, where if I had x cubed plus 8, you should immediately recognize that this would be divisible by x plus 2. All right, you can do polynomial division, figure it out. But this one's a lot harder. Now, you could guess and check, and that would take forever. You could guess like x plus 1, try it, x plus 2, try it, x plus 3, try it. That would take forever. But there is something called factor by grouping. And factor by grouping says look at each of the two terms and say, what can you pull out of each of these? Does everybody see in the first one, you can pull out x squared, and you get x minus 3. And everybody, you probably say to yourself, I'm going to pull out positive 9, right? That's usually what students do first. You get negative x plus 3. But what would happen if you changed the sign of this? If you made this negative, then the x minus 3 would be the same. And to save some time, I did that for us here. This is called factor by grouping, all right? So when we have these big 4-term, typically, polynomials, we can usually find some number. And now, think about it. You got junk here minus junk here. Well, what's common in two junks? X minus 3. So factor that out, and you're left with x squared minus 9. Well, x squared minus 9, we know is the difference of 2 squares. Now factor there, and then we have x minus 3 repeated, which gives us the final function here. X squared minus 3, or x minus 3 quantity squared times the quantity x plus 3. And we started up here with 4 terms, and we ended with 1 term and 3 factors. Right? 1 term and 3 factors. All right, and that's great, because otherwise, I'll love with you guys, if you can't get it to factor, you might as well grab a calculator, because to do it by hand is just too painful. So do we all agree there are no asymptotes? The domain of this function is all real numbers. I can put any value of x in I want. All right. So I look here and I say, well, I know the zero of these two zeros are both 3 and 3, or just 3, right? It repeats, but 3. And over here it's negative 3. And then you can build your sign table. And you say, my values are 3 and negative 3. And again, the hardest part about these problems is factoring. And again, because you're taking this quantity squared, I don't care if this is negative or positive. Because every time you get x minus 3 squared, it becomes a positive. And it has no effect on the sign. So here's our sign, S-I-G-N, sign table right here. And I already did it. Try to save us some time. I have x plus 3, the one factor that determines sign, shown. I have negative 3 and 3 shown where the zeros are. So I can put those on the graph right away. All right? And we know those are zeros. Negative, positive, positive. I know it's negative in here, positive in here, and then positive over here in these areas. All right? So again, I know a couple things about how these functions look. Because this is order 3, we agree that there can at most be 2 bumps, right? 1 minus the order. So we know an order 3 power can look like this, right? Well, the most you can do is this for an order 3. But that's the situation we have here. All right? So I just say, okay, I know it's negative to the left here. So I go down, I know it comes up, stays positive, hits 0, goes back positive. That's move. Not exactly the greatest graph there, but we can live with it. Again, it's a sketch, and it goes away each way. And we just graph an order 3 polynomial. The ones that you'll practice will factor. If they don't factor, you're done. Because if one of the roots is 1.796, we're not going to be able to really figure that out real well right away. All right? But again, while we learn here, we're going to factor. And this is why we learned about inequalities first in chapter 1. All right? Because we have to be able to make sign tables to determine where the curve is going. Yeah. Mm-hmm. Ah, okay. So so think of it this way. I put parentheses out here. And I pull this out. X minus 3 is in both those things. I put parentheses around the whole thing. Yeah, because at this point here, do you see this is one thing? This is one thing. What's the one thing that we gotta know? And that comes out here. Well, what's left? Well, pull something out, you're gonna have to put parentheses around the whole thing. Alright? And that will get us where we need to go. Alright? I have another one. We're gonna do another. This time I didn't do anything ahead, but also this one was pre-factored for us. Alright? You wanna give it a shot? I'll pause the video here. Alright. So the first thing I want to realize is, do we agree if you multiply all the x's out, 3 x's here, and 2 here, that's 5, 6, 7 x's. It could be x7, which could be 6 bumps, but I will tell you, because the 0 is going to because the 0 is going to repeat on x cubed 3 times, and the 0 is going to repeat here 2 times, I think it just bumps twice, all right? Or 3 times. It bumps 3 times. Yeah, because you forgot to use 0. It bumps 3 times, once, twice, and then each of those. I think I'm gonna make the table. I'm guessing. So that is the maximum it can be. All right. Do we agree the zeros? If I start making my sign table immediately, the zeros are, if I start, -1's the first one, right? 0, 2, and 4. All right. Those are the zeros, and that's just 0, -1, 2, and 4, and I just put them in order. Okay. Now, the only one that doesn't have effect on sign, you guys agree this does not affect sign, right? Because it's squared. The x cubed does. So I'm going to like x cubed here. I'm going to alternate sign. I'm going to have x minus 2. I'm going to have x minus 4. Those factors and that function effects. All right. Now we just have to go through and make our sign table. All right. 0, 0, 0, 0. So I'm going to plot 4 points on my axis here when I get there. I'm going to do the signs first. All right. X cubed in a negative area is negative. X cubed in a negative area. Now, sometimes it helps go all the way down. I'm going to go straight down the column instead of going across. Negative number cubed is negative. Positive number, positive, positive, positive. Okay. Negative number minus 2, negative. Negative number minus 2, negative. 1's in between 0 and 2. So minus 2 is negative, and then positive, positive. And again, a linear one, negative, 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 positive. Right, positive, negative, positive, negative, negative. All right. So here we go. I have a big old sign table. And I'm going to group it and make it a little smaller to give us some room. Save it over here. First thing I'm going to do then on my coordinate system, besides label the axes, -1, -2, -3, 1, 2, 3, 4, for the curve in green, -1, 0, 0, 0, 2, 0, 4, 0. Everybody understand that? Now initially, that's a big part of the score. Now I'll use my purple pen again. All right. It is negative over in this area, right? Out right here we're looking, got that sign. Here, this negative is in between right here, that little spot. Then it's positive in here. Then between 2 and 4 it's negative again. And then from 4 on it is positive. Alright, so it comes up and you notice here, x plus 1 squared, it's going to kiss the axis on it. Then x cubed happens multiple times, okay? But it's an odd number, so it's going to go through. So here I go, and I'll do it in blue. Alright, it has 4 bumps. Alright, I said 3, but it kisses the axis. It has 4 bumps because how many unique factors are there? 1, 2, 3, 4. This has 3 factors here, I agree, x, but x happens 3 times. So, that is the curve. It is ugly, but it works. And if you really want a good graph, what do? Grab a computer. This gives us a great sketch. It gives stability to do things, right? And this is why we learn those sine tables for inequality.